Hello, everyone. Welcome to our week 6 robotics class. So we are going to be moving into getting into talking about components of a robot. And so I'm going to explain what that is. But we've been going through a lot of review, right? What is a robot? We looked at the reasons for robots, and I really would like to move to a little bit more in-depth of studying the different parts of when you're actually building a robot. What does it need, and where do you even start with that, and what is the purpose of each of these components or parts of the actual robot? And the reason that we're going to spend some time studying this is because in a couple of weeks you will be using a virtual robot program. And if you don't understand the different parts of the robot, it will be very hard for you to be able to program it because you won't really know what you're programming. So I think it's worth it for us to spend some time going over these things and learning what they are, so that way you can visualize, oh, okay, so the robot, you need to use this, and this is what this does, and you have a better understanding of that. Okay, so we'll do an overview, and so we'll start this week. And so I would suggest right now to take out a piece of paper, get something to write with, so that you can jot down some notes. You don't need to copy the entire slide. That's not necessary, but you could just jot down some main points that we talk about. And obviously, you'll always have this video where you can go back and pause if you need to, because there will be a review sheet for your homework. So if you need to go back to the video and pause it to see any of the information again, definitely do that, okay? All right, so basic components of a robot. Before we get to that, let's review. So what is a robot? So this is our definition that we've been just talking about. We talked about it at the beginning of the year, right? We know that a robot is a machine. It's a machine. It's capable of responding to its environment to automatically carry out complex or repetitive tasks with little, if any, direction from a human being. So that is kind of like our core definition of what a robot is. So we know it's a machine. We know that it can respond to its environment, right? And we're going to be learning about which components help it to respond to its environment. We know that it needs to be able to do it automatically and little direction from a human. So it needs, like, if you remember, we talked about what does a robot need, right? The characteristics. It needs to be able to move. It needs energy. It needs sensing, right? To be able to sense around so that it can do what we're asking it to do. And it needs intelligence to be able to make a decision about whatever it's sensing in its environment. So these are really important things. So if you're struggling with the foundational definition of a robot, this is going to be on the review sheet again for your homework this week. Reason being, I just want you to solidify this in your brain. So that way, when you look at a machine, you should easily be able to determine whether or not it is a robot by looking at it and going through the characteristics in your brain and saying, does it have sensors? Does it move? Does it have some form of intelligence? Does it have energy source? And then you can say, oh, okay, it is a robot, right? Or the other way around, if you're planning to work on robots and maybe you want to build your own robot or design your own robot, again, you're going to need to be able to go and say, okay, how am I going to make this thing move? What's going to be the energy source of this thing? All right, so hopefully that's making sense to you guys. So our first component that we're going to be talking about is our body frame. So when you think about a human, right, we have a body, a frame, right? And then there's all the other parts of us, right? But we look like humans because we have our two legs, our two arms, right? We have our head. And robots can really, their body or frame can be any shape or size. And we've looked at a lot of different robots now at this point. So you guys should have a pretty good visual idea that robots, they look really different from each other, right? There are some that look like humans, but there's some that look like cars. There's some that look like, um, little boxes, right? Like, I mean, they have so many different shapes and sizes. And so essentially the body frame, it provides the structure of the robot. So you think about, you need to be able to design a structure that is going to be able to help the robot complete whatever task that you are asking it to do, right? So that's part of what engineers do. When they think about the body frame, the structure of the robot, they have to stop and ask themselves, well, what do I need it to do? And then, what type of structure would serve the purpose well, would help this robot to be able to accomplish the purpose that we're asking it to do. And so that, again, this is takes a while. This is a thought process, a design process that engineers have to go through when they are designing the robot, is really to think about the optimal body frame. So most people think about the human-sized robots. We see them in the movies, right? If you remember the documentary with Erica, and she looked just like a human robot, right? But in the majority of robots, especially here in the United States, industrial robots like we saw at a lot of the factories, they don't look anything like humans. They look just like robots. They look like machine robots, right? And so that's probably more of the norm that you'll see here in the United States. And then, of course, when you go to Japan and some of these other countries, you might see a lot more humanoid robots, ones that look like humans. But they're usually designed more for function than appearance, at least here, right? We're using these robots to help us complete tasks. And so really it's all about optimizing the design so that way it can do whatever it needs to do efficiently, right? Which means that it can do it quickly, it can do it with precision, where it doesn't make a lot of mistakes. And so it's something that we have to think about. All right, so I just put some possible body frame pictures here just to show you guys what they might look like. So again, this can vary so widely. Yeah, so really it's your imagination. Just use your imagination, be creative if you are designing a robot. Okay, another component or part of a robot that's very important is its control system. So if you can imagine, the control system of the robot is equivalent to the central nervous system of a human, right? So it coordinates, it controls all aspects of the robot. So that's something to really consider there. So sensors provide feedback based on the robot's surroundings. So maybe it has cameras to give it vision. Maybe it has infrared for it to sense heat. There's so many different sensors. It can sense how far it is from an object. It can sense the color of an object. And when it takes in all of that information, it needs some sort of a control system. And that's our central processing unit, CPU. Computers have this. It's like the brain of the computer. And what does it do? It filters the information, and then it helps the robot to make decisions, right? So it takes input into it, and it processes it, and it uses it. So the CPU helps it to then take that and make a decision of what it needs to do. If the robot hits a wall, then it knows that it needs to turn around, right? It depends on what it is that, again, that the types of sensors and the purpose of the robot. What task is it trying to complete? But your CPU, your central processing unit, is what's going to be helping the robot to do that. So it's helping to control all of those different things that it's doing. So hopefully this makes sense. And we're going to be in more depth talking about these things as the weeks go on. looking at some examples and trying them out in the virtual workspace. Okay, guys? So I just put, I don't know if anybody has ever looked inside of a computer before, but this is what a CPU looks like. And it looks pretty wild and crazy, right? But the robots, they have this as well in their control system. So just another thing for you to consider as you're designing and thinking about the designs of robots. Another main component or part of a robot is something called manipulators. And so it says to fulfill their purposes, many robots are required to interact with their environment and the world around them. Sometimes they're required to move or reorient objects from their environments without direct contact by a human operator. So unlike the body or frame and the control system, manipulators, they're not something that's integral, meaning that a robot can exist without a manipulator. So I just put a picture here to give you a better idea. But these little kind of like arms or little, they could kind of grippers to pick something up. These would be an example of a manipulator. So they can help the robot to be able to interact with the environment around them. If you remember the video with the robot that was swimming under the sea, it looked like a mermaid, and it had hands where it could actually grasp and touch things. That would be an example of a manipulator. It helps the robot interact with its environment and the world around them. And so, like robots in the factories, they might have a lot of these different manipulators to help them. So again, they can be a part of the robot. Okay, and they could take on a lot of different shapes and forms because robots, I mean, they're all so different, right? Okay, let's talk about the drivetrain. So this is really important. So some robots might be able to perform their task from one location, but a lot of the times it's required for robots, they have to be able to move from location to location. And that requires a drivetrain. Because what does a drivetrain consist of? A drivetrain consists of a powered method of mobility. Mobility means when you say something is mobile, that it can move around. So a drivetrain powers the robot to be able to move around, right? So for a humanoid robot, what would its drivetrain consist of? Legs, right? 2 legs. A car, what would its drivetrain consist of? The wheels, right? So a lot of robots do use some type of wheeled system. But again, there can be so many different varieties with your drivetrain. And when you're programming your robot, you'll notice in the code, there will be something that will allow you to control the drivetrain. You know, which direction is it going in? How fast is it going? And this is something that is important because the robot needs to be able to move to perform whatever task that we're asking it to do. So I put some examples. So here's a little humanoid with the 2 legs. This one has kind of like a big wheel, 4 wheels. There's just so many different types of drivetrains that can be out there. So that is that. Okay, so what we're going to do is next week, we're going to be talking about some of the subsystems of the robotics design system. And we'll talk a little bit more about specific things such as the sensors and different types of sensors. And we'll get a little bit more in depth into these things. So that way, hopefully you'll have a better understanding of what it takes to actually create and design a robot. So this week, what I'm going to be asking you to do is fill in this sheet, basic components of a robot. So the first question asks you, a robot is, it's our same question, and I like to put this on so that way you guys remember it and you keep it in your head, because this is something that's very important. The body frame provides the blank of the robot. Hopefully everybody knows the answer to that. The CPU, or what does CPU stand for? Filters information through the robot's programming and makes decisions based on logic. Drivetrain consists of a powered method of what? What does it do? And the drivetrain of a humanoid robot would be its blank. So fill in those questions. Please type them in and then email it to me. And this will be a good review of what we just learned. I didn't want to overwhelm you with too much, so I just kept it very short because I know that a lot of these concepts and things are new to everybody. And so I don't want to just overwhelm you with a lot of information in one sitting because I feel like that would just be too much to remember. So please go back, fill in this review sheet, and then email it to me. And next week, we're going to continue talking about some of the subsystems. Okay, guys? All right, have a good week. Let me know if you have any questions. Catch up on anything else you're missing with robotics. And I'll see you guys soon. Bye.